Hey, Algebra 2, it is Tuesday, and we are about to begin. I need to set up my camera. We'll be good. I hope Thursday's treating you well. We are going to spend some time doing trig identities today. No graphing, just kind of doing the algebra of trigonometry. Sorry, I'm just getting out of the camera started. And, oh, that's not working. Better, maybe? Oh, no, still laggy. Whatever, it should be fine. We are going to be doing trig identities today. I did not put this in the Dropbox, but I will right now. That. We have 2 sections left in Chapter 9 that I want to do, so Tuesday and Thursday this week. And then we will be done with any new content. We're going to skip a few sections, just like we skipped some chapters and didn't get to every chapter. That's fine. It's been kind of a weird year anyway. We would have probably gotten past Chapter 9 if it had been a normal school year. We would have also had a bunch of big tests, especially for juniors, that we would have prepped for, and a lot of things that would happen. So those aren't happening. So you don't need to worry about them. Just like we're not going to have a final. Man, my camera, why is it? I all understand. Huh. Don't know. Laggy. For the dark menu. Alright, sorry. We are going to. I just put the. I just put the student journal pages in the Dropbox folder if you need those or want to look at those. The student journal looks like this. We're going to be doing some trig identities, and I want to prove an important one, and then we're just kind of agree that these all exist. And normally we would spend some time proving some of the other ones and utilizing them and rewriting trig functions, using the identities and solving things. This is a big part of trigonometry and calculus. So if you're going to trigonometry next year or calculus your senior year, or you're going to take calculus in college, like these are going to get used a lot. And it all comes from Pythagorean theorem. Pythagorean theorem. Okay? And so we're going to focus on this Pythagorean identity right here, the first one. The other two are just the first one rewritten using different trig functions. So it's not anything different. It's still the same thing. It's just a different form. So we're going to prove that today, which I don't really want to do it on the whiteboard. Here, I have a better solution. I don't think this will dox myself. Just in case, we are going to switch to this. All right. I may draw some things on the whiteboard, but I want to prove we're going to prove it here. Okay, so first thing, let's draw some stuff because yeah. So remember our unit circle. We have our circle. We have the XY coordinate plane. We have some angle that's a standard angle coming out from the x-axis here. So this is some point x comma y. And then it's a unit circle. The radius is 1. All right, so the radius is 1 with some angle. That gives this value of x here and this value of y is the height of that triangle that gets made. Here's where the x value goes to. And then we can refer to different pieces in terms of sine and cosine, right? Sine of theta is opposite over hypotenuse, it's y, and cosine of theta is x. These two things we're going to use with the Pythagorean theorem. Yeah, I won't use the diagram. Use the because this is not a difficult proof. So we have the Pythagorean theorem, which is a squared plus b squared equals c squared for our right triangle. So I'm going to redraw this. I'm going to take this triangle out of the unit circle so I have more room, and then we're going to use this Pythagorean theorem. So a squared plus b squared equals c squared, and you're probably hearing me talk before it's written. I'm talking about it at the same time. I don't know what's happening. Here is the triangle. It's a right triangle. This is x, this is y, this is theta, and this is 1, because it's the radius. So let's fill in this thing right here. So we get x squared plus y squared equals 1 squared, which is really just x squared plus y squared equals 1. All right, 1 squared is 1. Now, we're going to put our trigonometric functions into this Pythagorean theorem, for x and y. Because remember, I shouldn't write this over here. Y is sine of theta, x is cosine. X is cosine of theta. So we just plug these in. So we get cosine squared of theta. Now you might think this is weird. Why didn't I write the 2 here? We write it this way so that we don't have to use parentheses, and so that we're not saying the theta is squared and then we take cosine of that. We're saying cosine of theta, all of that squared. This is weird notation. You're going to have to get used to it. Plus sine squared of theta is 1. This is the most important trig identity. Cosine squared plus sine squared equals 1. Or sine squared plus cosine. Yeah, or, right, sine squared theta plus cosine squared theta equals 1. This gets used a ton. A ton. And we would subtract, right? And you get cosine squared theta equals 1 minus sine squared theta. We can rearrange the pieces of this, which is really useful. And go back to our student journal. That's this. These are just if we divide by sine squared theta or cosine squared theta, and we get tan and secant. They're useful because they use different functions, but it's the same thing. Remember, tangent is sine divided by cosine. This is the definition of what tangent is. Cotangent is just the other thing. These are all the things we already know. Cosecant is 1 over sine. Here's 1 over cosine. Okay. This is just saying that sine and cosine are the same. They're off by 90 degrees, or pi over 2. They're the same. Same thing for tangent and cotangent. And then negative angles do things to the. So these are our trig identities. And really, you would just use these things. I would give you a printout of these, and we would use them to prove things. Like for example. We're not going to do that. We would do stuff like this. Okay. So we have negative tangent negative tan theta divided by secant theta. Okay, so to do these, we need to know our fractions. Tangent is sine over cosine. So here we have it written. Whiteboard. Tangent is sine over cosine. So I can rewrite this as sine theta divided by cosine of theta times 1 over secant theta. Same. Secant theta, if we go back to our student journal and look at our chart, secant theta is just 1 over cosine theta. Right? This, just 1 over cosine. So sine theta, cosine theta is 1 divided by times 1 over cosine theta, which this simplifies to be sine theta cosine theta times cosine over 1. Because it's a fraction being divided, it just flips over. And so then our whole thing, these cancel out, and we get sine theta. Now it should be negative. We took the negative from all these, so it should be negative something. The negative tangent of theta divided by secant of theta equals negative sine theta. And we can check this very easily. Check this very easily. I'm going to check it by graphing. So we go to Desmos. Desmos. So we're saying that negative tangent of theta, or x, divided by secant of x, this should be the same. I should get the same graph if I do negative sine of x. And you'll notice they overlap perfectly. So the same thing. So that's what we're going to do. That's what we would do with the identities. We're just rewriting kind of complicated functions, the tangent x divided by secant x. We're simplifying, we're replacing things. We're maybe making it more complicated to simplify it further. So that whole term tangent into sine and cosine, it complicates it a little, but then it simplifies later on. Okay. So we can do that. You'll notice we get more complicated ones. Stuff like this we would have done. We would have figured that out. But I'm tired, and I think I'm done. Because if you're doing trig next year, you're just going to do all this. And if you're going to do statistics next year, you're not going to do any of this. But that's what we would do. We would simplify these things by substituting and replacing and dividing. Okay? So I think that's it for me today. That's all I want to do. We're getting to the end of the semester. I'm winding down. We're all winding down. COVID makes everything weird anyway. So what we're going to do is we'll meet again on Thursday. I'll have another short video. We'll do the final section that I want to talk about for trigonometric functions. And then we have a week left of school. This week and next week. Grades are due at the end of next week. So what's going to happen is next week, instead of doing YouTube, we're just going to have Zoom meetings. So I'll schedule those, and I won't come with an agenda other than if you need help on an assignment, turning it in, prepping, doing some sort of makeup, I'll be available on Zoom, and we can talk about the specific problems. And I have all the Dropbox, so I can pull up the files and we can talk about the specific problems. I can open the textbook on the computer. We can talk about any specific problem. So I'll send a Zoom invite later, send some reminders. But that's it for today. So I hope you have a good Tuesday.